In this video, we'll be creating event-driven workflows using Azure Event Grid. But before we start, why event-driven architectures? Typically, they go hand in hand with serverless consumption models, so can be cost-effective. Producers and consumers are typically decoupled, which leads to highly scalable and distributed systems. So let's consider a scenario where you need to perform some guaranteed processing on files as they are uploaded to Azure Blob Storage. Perhaps resizing image thumbnails, image recognition, or text analytics, for example. We'll start off by creating a storage account which would act as the source of our events, so we'll house a blob storage container where we'll be uploading some images. We'll create a new resource group for all of these resources, switch to locally redundant storage, and deploy into our Azure region of choice. As we'll be creating a few Azure resources in this demo, we'll give this the name of source to make it easier to identify it's the source of our events and the beginning of our process. We'll also go ahead and create another storage account. This second account will be used for Azure storage queues. We could put the images and the queues into one single blob storage account. However, we'll split them into two so that we can ensure each process has the maximum potential allowed from an IOPS perspective from the storage account. We'll clearly name this one with the queue name, also deploying it into the same resource group and Azure region. At this point, we'll create a blob container in our storage account where we'll upload our images. We'll also create another container called thumbnails to illustrate the scenario of an image resizing workflow. We'll also create a queue in our second storage account and we'll call it work in progress. Now we have everything needed to set up the initial stage of our process. After navigating back to the source storage account, we'll click on the Events menu item and we'll create an event subscription. If you're familiar with messaging theory, you'll understand that we commonly have topics and subscribers, sometimes known as a publish-subscriber model. In this instance, the Azure storage account will be our system topic, and we'll be creating the event subscription, which will send the messages to an event handler. And think of this event handler as the receiver. We'll give the event subscription a name, like Image Creation Event to Queue. We'll give the system topic a name like Image Created in Source, and we'll adjust the filter so that we only push blob created events to our destination or the event handler. Now for the destination or the event handler, we can select several services, including Azure Functions, webhooks, storage queues, event hubs, hybrid connections, service bus queues, or service bus topics. We mentioned in the beginning of the video that we need to guarantee processing of the file process, so it makes sense for us to send the event directly to a queue for further processing. We'll select the storage queue that we'd created earlier. We're also going to enable system managed identity for our permissions for an added extra layer of security, eliminating the need to store any credentials in code, but more on that in just a moment. Finally, we're going to navigate to the Filters tab and enable subject filtering so that we only deliver events that are from the images container. If we didn't apply this filter, then we would receive creation events for blobs created across the entire storage account, whereas we're just interested in the ones from the images container and not the thumbnails container. There are some additional configuration options around dead lettering and retry policies where you can see there are some defaults already configured. You can also see that we can configure properties for the delivery location. In this instance, the TTL for the messages that will arrive in our storage queue. Before we hit create, let's cast our minds back. Remember that we created a system managed identity? Well, once the event grid topic has created, we'll need to make sure the managed identity associated with it has permissions to write to the Azure storage queue. By default, it will not have those permissions granted. At this point, we can see that we now have a new event subscription created. If we navigate back to our resource group once again, you will see that there is now an Event Grid System Topic resource in the resource group. If we click into the identity menu of this Event Grid System topic, you can see that the status is enabled. From here, we can also assign the needed permissions by clicking Azure Role Assignments. We'll want to assign the storage queue data message sender permissions to the Azure storage account containing our queue. This enables the appropriate permissions to put messages onto the queue. So at this point, we've gone ahead and created an Event Grid System topic, an Event Grid subscription that is bound to the system topic, which sends messages to the Azure storage queue, and have also configured the system managed identity to allow the messages to be sent to the queue. After a bit of time, we can hit refresh and see that the identity's permissions have been updated successfully. Let's navigate over to the source storage account and upload an image to the images container. You'll notice that as we navigate to the events section, the metrics haven't yet caught up that an event has been triggered. Instead, we'll move across to the queue storage account and take a look at the queue because we'll now expect to find a message waiting for us. There it is. Brilliant. Now let's prove that we are filtering those messages. We'll upload a new image into the thumbnails container in the source storage account. Once we navigate back to the queue storage account, you can see that there is still only one message on the queue. We now need to create a consumer to process the messages which get sent to the queue. We'll create an Azure function to do this, as we'll continue receiving the benefits of a scalable and cost-efficient process, only triggering when it's required to do so. Event-driven. We'll use the built-in trigger capabilities to start the required processing when there is a new message on the queue. There is also an event grid trigger available as well, but as we mentioned earlier on, we'll be using a queue to ensure that the file is processed before removing the message from the queue. Alternatively, when sending events directly from Event Grid to an HTTP endpoint, Event Grid will typically consider messages delivered once certain status codes are received. When using Azure Functions in these event-driven technologies, it's important that you read up the documentation on how each of the individual triggers work that you are using, as they are all implemented slightly differently. Likewise, make sure that you understand thoroughly how the messaging technology that you're using works. For example, the differences between Azure Storage Queues and Azure Service Bus Queues, as they will have different guarantees around message processing, duplicate detection, etc. Now back to the Azure function. Typically, I create my Azure functions as C# projects through VS Code rather than C# scripts in the Azure portal. But this is enough for the purposes of the demonstration and keeping this video short. Like any software, you should ensure you have appropriate development lifecycle in place, i.e. source controlling, building, and releasing your source code. We won't be doing anything adventurous in this function, so we'll leave this as the basic code sample, but instead I'll add some comments to represent the steps that we would have taken in code. Now, once we navigate back to the Azure Storage Queue, you will see that the message is no longer there. The Azure function has successfully triggered and processed the message, so it has been removed from the queue. Excellent. But let's prove this once again by uploading another image to the source storage account's image blob container. We'll navigate back to the queue, and we can see that there are still no messages. And that is because the Azure function has already identified the new message on the queue and processed it as a result. Navigating over to Application Insights, we can begin digging into the performance metrics of the Azure function and looking through the logs of the function's execution. Now, when we look at the resource group, we can see that we have the source storage account, the storage account containing the queue, the Event Grid system topic, and the resources relating to Azure Functions, or the consumer of our queue. Navigating to the source storage account's events, we'll see that the metrics show a number of events successfully delivered. Navigating back to Application Insights, we can now see the logs from the Azure Function's output, showing that the Azure Function printed the expected output with the contents of the message in the queue, or the original event from Event Grid successfully. To take this one step further, we could go ahead and use those details in our Azure Function to perform the needed processing on the original image and place the updates into the thumbnail container. And that completes our end-to-end event-driven workflow.